Hello, my name is Victor.
My name is Kintera.
I'm Gustavo.
And I'm Tro.
And today we'll be talking to you about Project Problem 3. Our problem is find the volume of common two circular cylinders, each with a radius of r, if the axes of the cylinders intersect at a right angle. Solution. Step 1, we want to understand what we are given. And then step 2 is apply the equation for the volume of a solid.
So we need to understand what we are given.
A Steinmetz solid is the solid body obtained as the intersection of two or more cylinders of equal radius intersect each other at right angles. The shape when viewed from different angles can be seen as either a square or a circle. When looked at from the side, it will appear as a circle, but when looked at from the top, it will appear as a square. The solid is formed among three different axes. The x and y is the traditional flat coordinate plane, while the z is the plane that will give the third dimension that would give volume to the solid.
Applying the equation for the volume of a solid. The volume of a solid is found by the equation B equals the integral from A to B, which is the x values that the solid lies between, of the area of the cross section. It is important to remember that the area of the cross section is a moving slab obtained by slicing through the perpendicular x-axis. The Steinmetz solid, when viewed from different angles, can be seen as a circle or a square. Here we will take an arbitrary slice along the z-axis, and that slice will relate to cylinder 1 and 2, but the initial slab we take only accounts for a corner of where the cylinders meet. So in this case, we have 4 sub-squares. This is where we get the area of the slab multiplied by 4.
Area of the cross section. Since the solid is created with two cylinders of radius r, x, and z related by x squared plus z squared equals r squared, the area of the square is a equals x squared, which in terms of z is x equals root r squared minus z squared. The area of all the squares is 4 times x squared. Ax equals 4 times root r squared minus z squared end parenthesis squared. Therefore, V equals, or volume equals, 2 times the integral from 0 to r, definite integral, 4 times the root r squared minus z squared, all to the power of 2, which technically is just 4 times r squared minus z squared. And so we're left with the work. So we begin by pulling out the coefficient out of the integral. So we're going to get 8 on the outside of the integral. Then we begin to integrate. We'll have the integral also with the bounds not applied yet. Next, we apply the bounds. So we might subtract the r plugged in, subtracted by the 0 plugged in. And now we have 8 bracket r cubed minus r cubed over 3 minus 0 end bracket. And all we do is continue to simplify here, and we are left with 16r cubed over 3 units cubed volume.
Conclusion. To solve this problem, we begin to start finding the area of the slab, then integrate to find the volume. We created a formula for the area by using the circle equation and the area of a square. Then we set up an integral from 0 to r, multiplying the integral by 2 because we only found the top half with our initial equation. After we do all of this, we integrate, and then we find our final answer. 16r to the power of 3 over 3 units to the third.